chat. Okay. Thanks for that introduction. And thanks for honestly for running this group. I've really enjoyed the ones that I've come to. Unfortunately, because of my teaching schedule this past quarter, I haven't had a lot of time because I was teaching two classes. But I think the conversations have been really good. I apologize if I mute at random times to sort of cough off screen. I am coming off of the end of a cold or something that might be COVID if my rapid tests were false negatives. Um, and so I might have to pause and like blow my nose or whatever, but I'll try at least not to do that with audio. Okay. Um, ggdist, yeah, before I get into ggdist briefly, yeah, so sorry, is it May as a short form or what is, I can't remember, what you normally go by.
I go by Gina. I'm sorry. Yeah, I should put that
Gina,
on my.
okay.
Yeah.
Yeah, okay. Um, Thanks for the introduction, Gina. Yeah, so I'm an associate professor at Northwestern. I was previously also at the University of Michigan, and I spend a lot of my time thinking about how to design uncertainty visualizations. And way back during my PhD, um, I was doing this in like 2015, 2016. Um, and not only thinking about designing how to design uncertainty visualizations, but also how to build tools to make it possible to create them. Um, and I was really using a lot of Bayesian models and trying to figure out how to post-process output from those models. And that led to actually a package I'm not going to talk about today, which is tidyBayes. So tidyBayes was kind of the original sort of progenitor. At some point, I realized that a lot of the functionality in tidyBayes for distributional visualization is useful not only for uncertainty visualization, but also, distributions from, say, raw data or samples. Um, and so I kind of split them off because I had observed that maybe some people were hesitant to adopt a package with Bayes in the name if they weren't doing Bayesian statistics, when maybe it was actually useful for a lot of other things. So I think maybe in 2020 or so, I split it off and created ggdist as a separate package from tidyBayes. Um, so yeah, I'm gonna maybe do something a little bit weird today. So um, ggdist was this package that was born of basically my annoyance. Uh, and I'm hoping that Zoom is doing the correct thing and you can actually see the top here because I can't because I put your faces over this. But it was essentially born of my annoyance at trying to post-process samples and construct uncertainty visualizations in ggplot2 and construct distributional visualizations in ggplot2 in a way that I felt was sufficiently flexible. Um, and so it is, a package, but it is also an attempt at a formal description of uncertainty visualization in the grammar of graphics, so that it is possible to create a wide variety of uncertainty visualizations. I think that when I think about like package design and API design, I think that the best complement that you can get for
Sorry,
as
Matthew.
a yeah.
We can't really see under the top of your
Oh, you can't see under
slide. So
this.
Yeah. Maybe
would you mind just reading what it says?
or putting
Uh,
the
I
panel
I
on the
can
bottom, maybe
I
if
can do
you.
you one better. I'll just move this somewhere else. The only reason I put that up there is so that I can see your faces when I look at my camera. But if you'll just accept that I'll have to look down here to see you, that's fine. I'll put you on the other screen. Sorry. Yeah. So I guess Zoom wasn't doing the correct thing. I thought normally it will composite that so that you can see through that. Oh well. My apologies. Yeah. So ggdist is yes, it's a package, but I think that like to me, an API is best if people can do things with it that you didn't expect them to do. And so I really want it to be something where it has the flexibility to create weird uncertainty visualizations and even uncertainty visualizations from the literature, but also ones that, I haven't really thought of. And so I've thought a lot about the design of the thing to construct it in a way where it makes it really easy to basically do weird things. Um, and so I'm actually going to talk about not so much the syntax of ggdist for the first part of this talk. For maybe about 15 minutes, I'm more going to talk about the theory behind it. And then I'm going to sort of just transition into let's do a bunch of live coding and have a conversation because there's so many things I could talk about that I don't really want to, prescribe that conversation. I kind of want to base it on what people might actually be interested in. So I'm actually not going to talk about code for the first 15 minutes. I'm going to talk about what is a formal description of uncertainty visualization in the grammar of graphics. Um, and the thing that I do want to point out, though, is that the design of ggdist is intended such that these two things are fairly close to each other. So while I'm not going to talk about the code on the left, and I'm going to be talking about something more like what's on the right here, um, if I were to show you the corresponding code, it would look very similar, just as these two things do on the slide that's in front of you. The main difference here, when I talk about the grammar of graphics, is uh, I'm just going to swap the order of these two things. Um, so when you look at like aesthetic specifications in ggplot, right, you usually have something being assigned to some variable. But when I think about this, and often when people who think about visualization, sort of more from a research perspective and more from a formal description perspective, we often swap this around. What we're actually talking about are functions that are mapping things from the right-hand side onto some space defined by the left-hand side, right? So I'm talking about things like, I have a random variable and I want to map that onto some positional aesthetic, right? And so I have some function that's transforming from things in data space to things in a positional space that determine where things end up. I might have some function that goes from uh, takes density values associated with this random variable and maps them onto, say, the thickness of this kind of slab geometry thing, which is what I've ended up calling these kind of shapes. And so this is actually defining some function that's transforming between these spaces. And so I like to write it this way. Um, Hopefully this will become a little bit clearer as I go through this. And please interrupt me as Chen did if there's any clarification or questions, or just, something controversial you want to say so we can have a conversation. So ggdist is based around three families of geometries. The interruption was not rude. The interruption was welcome. Uh, it's based around these three families. So slab interval, dots interval, and line ribbon. They're these composite geometries. They actually have subgeometries of so point, interval, and slab here, point, interval, and the dots here, and the line and the ribbons here. Um, that you can either use as a composite geometry, or you can also create separate geometries. So there's like, geom slab interval and geom slab and geom interval and so on. I'm going to talk mostly about slab interval for the theoretical portion of the talk, but most of what I say kind of generalizes to the rest of this. So when you first start thinking about visualization in the grammar of graphics, often you're talking about simple positional mapping. So say I have a variable mu. I want to plot it on the screen. I need to determine its x position. I set up a positional mapping, so mapping from mu onto the x position, and this just determines how far horizontally in pixel space or whatever space I'm actually physical space that I'm using to create a visualization, this dot is going to be drawn, right? And that mapping has like a scale function associated with it, and that's how you end up with things like axes and legends and whatever, but I'm actually not going to talk about that for most of this talk. Okay, so if I want to inject uncertainty into this idea of positional mapping, a reasonable starting point is to say, replace that point with a distribution. And in this case, I think about what I think of as sort of like a pseudo aesthetic, which is the distribution that's associated with the exposition. Um, and so now I have kind of underneath this point a distribution that I can then use to construct other mappings, right? Um, so a simple example, often the very first thing people think of when they think about uncertainty visualization is I want to plot an interval. What is an interval? Well, an interval in this case, if I have a distribution underlying this point, might be something like the 2.5 quantile being mapped onto the x min, so the lower point of that interval, and the 97.5 percentile or whatever you have being mapped onto X max, so the upper point of that interval, right? Um, and the idea here is if I have a way of specifying these things such that if I've mapped this random variable onto the ggdist aesthetic, I then have access to the density function, the cumulative distribution function, and the inverse cumulative distribution function, so the quantile function, which is this function right here. Um, I can then very naturally say, okay, I want to map the 2.5th percentile onto x min or the 97.5th percentile onto x max. Um, but this is actually, in a way, not really what I want to do, because this ties the way that I construct the interval to how I specify it. And if you've seen, let's see, actually, here's a point where I can show you an example, I suppose, from the documentation. Let me see. Probably have something here. Something like HCIs. Yeah. So if I look at the problem with that way of thinking about things is if I look at wherever I just was, that will define what's called a quantile interval. But if I have a distribution that's not symmetric, I might want something like a highest density interval. And so I don't necessarily want the way that I think about interval construction to be quite looking like this. What I really want is something maybe a little bit more general. So one example might be I associate a mass, which I'm just going to call gamma here. Um, I create an aesthetic associated with the mass of the interval, and then I allow the function to basically take that mass and construct an interval based on it. So these two things here are equivalent. Basically, all I've done is I've factored out this mass, and that determines both the lower and upper point of the interval if I'm using a quantile interval to draw this. Now, what that does is it takes this number out of the equations and it allows me to actually turn it into something that could be data that I could then map onto other aesthetics. Why would I want to do that? Well, maybe I take two different intervals, like the 66 percent interval and the 95% interval, and I map that mass onto the line width of these two lines, right? So now I have two intervals, and I can easily create these nested intervals. The syntax in ggdist is just going to be the level, which is a variable generated by the stat, mapped onto my line width, so like AES level equals after stat, or line width equals after stat level, something like that. Um, or, maybe I want to map it onto lightness and get these kind of like nested sort of gradient style intervals. Maybe I want to increase the number of levels. Um, this is actually another nice sort of situation where you can pick masses carefully to create effective uncertainty visualizations. So these masses on a normal distribution will be approximately evenly spaced and also are kind of vaguely nice looking numbers. So what that means is if you have a distribution that's not normal and you plot it like this, you can actually see that it's not normal because you'll see that the spacing becomes uneven. So you can kind of use both you can use the style of visualization that you're using actually to inform uh, the masses that you pick in order to kind of like construct a visualization that actually tells you more about the distribution than it otherwise would. Uh, yeah, Michael's saying using multiple line widths or coverage ranges is important, should be made as easy as possible. I agree. Like this was a lot of the motivation for this to me was getting people to not think that, 95% or whatever arbitrary number you choose is sort of canonical in some meaningful way, right? Um, Seeing that there are multiple levels ideally helps you kind of think about the fact that that choice is sometimes a little bit arbitrary. But also, as I'm saying here, like allows you to also think of other principles that would allow that choice to be less arbitrary, like choosing sets of masses that allow you to see properties of the distribution, like how heavy the tail is. Um, so you can generalize this to line ribbons. You can do the same thing with line ribbons. You can like pump up the number of levels so that you get gradients. And all of this can be done, within the same abstraction without sort of needing to add a whole bunch of other features to the theory or the API or however you want to think about it. Um, What else can you do? So density plots are the obvious thing. Everyone loves to make density plots. The way that ggdist handles density plots is it actually creates its own positional scale that is a subscale on the off axis that I decided to call thickness because I was keep basically a lot of this like slabs, thickness. It's just me trying to come up with synonyms for things that people have that are not used somewhere else in the ggplot universe, right? I feel like this is just like part of API design, right? And so at some point, and I don't remember why, I basically came up with, well, I can't use like area, I can't use ribbon, so I came up with slab, and then I was like, well, I need some name for this fake aesthetic. I eventually decided to call it thickness. So density plot is just a mapping of the density function onto this thickness aesthetic. Um, ggdist does a lot of the really annoying things that you would want it to be able to do. So, if I have a factor on the off axis and I'm mapping density, or in this case, it's actually probability because this is a discrete distribution onto the thickness aesthetic. Um, it's going to scale all of these to have the same scale, which means it will have the property you want, which is all of these shapes have the same total area. Um, and then you can also do other things, right? Like, so this particular visualization is also mapping that probability onto um, the color hue of or actually the color scale of the bars themselves, right? Um, Gigi just does also a lot of the really hairy, annoying crap. So, if you were to naively start trying to do this, it would be much more annoying than you might at first think, because what this is actually doing is it's constructing a geometry where you need to evaluate this probability mass function at a whole bunch of points in order to create these bars. Uh, if you want to also make it such that people can map colors arbitrarily onto these bars and it actually fills the bars incorrectly, you also have to think about um, you have to evaluate it here. You have to evaluate it at the top of the bar. You also have to basically evaluate it at like those points plus or minus epsilon so that if you uh, make an expression like, map the probability of X less than some threshold onto color, you want it to be the case that it colors in whole bars, which means that condition has to be true just left of a discontinuity and false just right of a discontinuity. So basically, there's like a bunch of stuff here that you don't want to have to deal with that GG just tries to deal with for you to make plotting these things sensible. Um, it also handles dodging correctly, right? So it will correctly position these subscales and maintain the total area constraint if you use dodging um, as you might naturally want to do with geometries. Okay. Other weird stuff you can do. I like to just think of it as like, okay, this is a tour of some weird things. Let's think of a crazy idea and see if we can do it. So you can map the density onto the alpha of the geometry. ggdist also has since whenever Paul Murrell wrote all of that awesome gradient stuff in like R4.1 or whatever it was. ggdist takes advantage of that. So these are real gradients. They render nicely. You can do weird stuff. So this is something weird. Back to what I was saying at the beginning, like, okay, I want to be able to um, create charts that I wouldn't have thought of. So this is an uncertainty visualization from the literature from this paper by Grell and Gleicher in 2014. Um, and basically, they had the idea of, okay, another way of trying to get people to not focus on the arbitrary 95% boundary. So this is the 95% interval, the gray in the background. This interval in the middle is probably like 50% something. Um, Maybe one way of doing that is to actually have it kind of fade a little bit. Well, you can create an effect like this by mapping this maybe slightly weird looking function onto opacity. It's actually not a weird function. So what this is basically a consonance curve. So this is a reflected CDF. Um, or if this was a say this was like a t-test, this would be your p-value function for like a two-sided t-test, right? Um, and so basically what this is horizontal slices through this function are horizontal slice at an alpha of 0.05 is the 95% CI, so the 1 minus alpha CI, right? Horizontal slice at zero point 0.5 is the 1 minus alpha is also zero point 0.5 CI, right? So this is actually a useful function, and you can write this in just a tiny little bit of our code. It's like negative p max of the absolute value of blah 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 blah, and so it's a nice way of basically just creating this weird visualization. Well, you can combine it with other stuff too, right? So you can do this was from a different paper in 2021 where they were combining this gradient idea with your sort of violin plot, right? So you map the density onto the thickness and also have these little faded tails. You maybe you do something else, maybe you discretize it. So the other thing you can do is you can take the masses of nested intervals and you can map them onto alpha or color or whatever you like. Um, and all of this is sort of handled under the hood in a way where you mostly don't have to think about it. And you can kind of do these combinations arbitrarily. Um, Basically, what ggdist is doing is it is at the stat level constructing a grid over this horizontal space and evaluating like the density function, the CDF, and then also giving you the mass of the uh, smallest interval that contains that point, right? And with those three things, you can essentially construct a lot of the rest of these crazy visualizations. Um, so long as it also does things like handle uh, either doing gradients to do colors within the geometry or splitting the geometry up, you can pick one or the other. Um, so on the implementation side, there's a lot of work to make this happen. Um, but once it's there, you can make things that are annoying very easily. So this was actually a quote from that paper, which I like because it's like 3 lines of ggdist. Um, Other cool things. So, excuse me just for a second.
Are the examples coming from like ggdist usage, or you're just showing examples that could be made with ggdist? Or
Some of them are coming from usage, some of them are coming from literature where I've, read a paper and I was like, oh yeah, I could totally make that with this. Um, some of them come from, previously conversations on Twitter, now conversations on Blue Sky, or someone posting something on a GitHub issue, and then I'm like, okay, how could we do that? the funnest versions of those are when someone posts something on a GitHub issue and I'm like, oh yeah, we totally can do that, right? So like that example I gave earlier on, that was all of the Poisson distributions with the color gradients with the histograms that came from a conversation on Twitter uh, where someone wanted to make something like that, and I was like, oh yeah, we can already do that, and kind of here's how it goes. So those are like the funnest conversations to me because if I can already make it, that's cool. If I can't make it, then it's like uh it's a fun challenge to figure out how do I extend the formalism such that I can make it, right? And that's always the challenge because it's like I don't want to just say, okay, someone wants a feature, I'm going to add a feature. It's someone wants a feature, what's the generalization that causes that feature to be like an accident of the design of the API? Which I feel like is the cool to me that's the cool way of thinking about API design. Maybe that's like the computer scientist in me or whatever. Um, yeah, that's a really good question. So okay, so this example was fun because this was uh, this visualization that Wilkinson called a fuzzy gram, right? So a fuzzy histogram, which you can generalize to the idea of a fuzzy bar chart. So what this visualization is it's just mapping the complementary CDF onto the opacity. But if you think about this, one of the reasons I like this visualization is you can think of it as like a sort of like generative story for how this visualization comes to exist, which is like if I had a bar chart and I wanted to add uncertainty to it, one way that I could do that is if there's a distribution associated with that bar, I just sample a large number of bars from that distribution and then plot them all on top of each other with decreasing opacity until I get something that looks like a gradient, and it would look like this. And that, but when I write it in ggdist, it's quite simple. I just map the complement of the CDF onto the opacity. Um, oh, so I can, do the usual ggplot2 things, right? I could map some other variable onto the y-axis and create these kind of fuzzy looking bar plots. Oh. Okay, this basically ends the theory portion of the talk. There's a bunch of other crazy things you can do with ggdist. You can create like dot plots. You can create someone made this nice tutorial of like they were trying to visualize logistic regression and they were like, okay, I have like the fit from the logistic regression model. I can take some dot plots and like mirror them and kind of create this nice little like logit dot plot sort of thing. The dot plots in ggdist actually maybe this is a good time to do a little bit of interactive code. The dot plots in ggdist also were born of annoyance. So there are a lot of things about dot plots that I think are useful and interesting to think about, but one of them is um, let's see, let's just make like a bunch of uh, values. Uh, um, so the dots geometry in, oops, uh, what am I doing here?
You have X is Y.
Oh, oh, right. So the dots geometry in ggdist, this is totally not about the theory of the thing, is designed to solve a lot of my annoyance with dot plots, which is basically that I really hate trying to figure out what the dimensions, what the bin width needs to be in order to actually plot the thing. So it will just figure out the bin width so that it actually fits. Um, and you don't have to deal with it. And you can also do this on categorical axes and you can map aesthetics onto dots at the subgeometry level. So I could I don't know if I wanted to do something like let's say fill equals x greater than 2 or something like that. Um, you can do this kind of thing. Now, the reason why I find that interesting is, whoops. So basically what this is doing is it's automatically finding a bin width across all of the dot plots in this set such that they fit within their vertical space. Um, but then, I can do the subgeometry mapping type stuff, and that allows you to do some cool things. Let's see, you can create like rain cloud plots. Um, you can Bird Bassiter is his pseudonym, but Michael Corral is another Viz researcher who likes to he's a very funny individual. He posted this on Twitter. This was years ago. This was 2017. And I was like, oh, you know what? With all of the I think this was just around the time that RAG came out. And Thomas was working on like making fonts like not suck. And apropos of the last talk. Um, and I realized that like because the way that ggdist works with its dot plots, it's actually just text. So you can use emojis with ggdist dot plots. Um, so you could create a manual emoji scale in order to replicate basically this weird dot plot thing. Right. So literally, I'm just mapping, I'm creating a manual shape scale and assigning it these two emojis and saying that when it's greater than that value, I want it to be one or the other. Right. Um, so that was another fun one. So this is the blank slide. This is the part where we've got another 20 minutes. I'm happy to take questions. I'm happy to show you actual syntax. I'm happy to talk about like weird API design things or crazy things that ggdist does that makes your life easier. I'm happy to talk about really anything at all. So yeah, I'll move people's faces back up so I'm not looking at my feet
Yeah,
while we
thanks,
do
Matt.
this.
That was a really interesting presentation. And yeah, that it's clear that you put a lot of thought into the design of it. It's exciting to hear you talk um, about the generalizability. And yeah, that's really fun. Yeah, so we can open it up to questions. If any of you have them. Okay, Corey
Uh,
is often our first question asker, and here, yep, he's not failing today.
Yeah, I have an excuse today because I was completely late to the presentation. I'm sorry, I only caught the last 5 or 10 minutes. Something that I want, maybe you address this, maybe not, but I wonder whether it's more or less automatic if you have distribution generating functions like the DPQ stuff that for
yeah.
certain distributions already in R, or if ggdist has some internal helpers to to handle distributions that are not part of an existing package that you're using. Like if you have some kind of custom Bayesian distribution, or it's like the plausibility distribution they call the p-value distribution, random stuff that like does ggdist contribute statistical frameworks like that, or does it require the user to have a framework available?
Yeah, so that's a great question. So if you have like the DPQR functions, there are two different ways you can use them. So originally there was actually what's going to be the easiest way for me to show this? I'm going to move people away again because that is actually less good than I thought it was going to be. Let's see. I can just pick a random thing here. I'll just pick this one. Um, so there's a couple of ways of doing it. Actually, I need this stat. Just go to stats. Um, so if you have the DPQR functions, you can map basically the stem of that onto the like xdist or ydist aesthetic, and it will find those, and then you can map like the arguments to that function uh, onto maybe it's actually easier if I just show you.
And it can Actually, so does it require all four, and does it know to look in the working namespace, not just the
Right. So if you have a more complicated thing like you want to do in another package, what you would actually want to use is dist wrap. ggdist originally wasn't built on top of distributional, but then as a weird amusing like happenstance, Mitch, who wrote distributional, and I were both submitting our updated versions of our packages on the same day, and we were both looking at CRAN says to look up our the state of our package submissions and noticed the other person's package name. And then we had a conversation on GitHub where we were like, wow, this is actually really useful. So distributional is a great package that Mitch wrote that basically creates distribution vectors. Right. So I can do like, you know, let's put something like this, uh, and get, you know, a vector of distributions. I can also use dist wrap, which is uh, where you specify the name and whatever arguments. And these are using the DPQR functions. ggdist doesn't need the R, but it needs DP and Q. So as long as you have DP and Q, you're fine. And in this, you can specify package, which could be a package or it could be an environment. So if you have it in a weird spot, you could use dist wrap to do like a more custom distribution if you wanted to. Yeah, so that's actually the so the question of like, does GG just have like a bunch of ways of handling this? Yeah, so um, it has this giant file that I probably wouldn't want to get into, which is basically the wrapper around all of the garbage of different distribution APIs in order to make it so that you don't have to deal with that stuff, in order to make it so that you don't have to deal with like oh, you know, I'm visualizing a discrete distribution and I want it to actually like show up because it needs to be evaluated at you know, a spike, right? Like all of these sort of annoying things that you don't really want to deal with. It's not perfect. There are still some situations where it won't do everything that it needs to do, but for like 95% of cases, I think it covers a lot of the weirdness that you're going to run into with univariate distribution visualization anyway. Yeah.
Tim and then Michael.
Yeah, thanks, Matthew. It was a lovely talk. I'll first raise Will's question in the chat, which is, what is the craziest viz you've made with ggdist?
What is the craziest viz I've made with ggdist?
Yeah, apparently Will was not satisfied with the poop emoji.
Oh
Viz.
yeah, I mean that's probably one of the craziest ones. So let's see. I mean, a lot of
I
them end
guess,
up in the documentation, so I can just like scroll through and see if there's something weird that I.
yeah, I guess by crazy I meant like like complex, not like weird.
Oh, interesting. Well, I try to make it so that the visualizations aren't complex. I feel like that's kind of if you mean like in terms of complexity in the code, uh, that's like the opposite of what I want, right?
Oh yeah, sure.
Uh, I
Um,
mean, some of these are weird because you have these like multiple mappings of
yeah, these are all great. These
uh, oh, actually, you know what?
ooh, that one is interesting. They're
This one?
all great.
Oh, so this was inspired by Tukey had this interesting argument in a I can't remember if it was a paper or where it was. I have the citation somewhere here. Um, whatever. If that'll load. Anyway, whatever. Someone can look that up if they care. Basically, you had this visualization that was pencils, where I think the inner point of the pencil was maybe an uncorrected 95% CI, and the outer, like the, you know, the base of the triangle of the pencil was like a multiple comparison corrected CI. And basically, his argument was, wouldn't it be interesting if you, instead of visualizing, having the visual weight be focused on where things are have the visual weight be focused on where things probably aren't, right? And so this is not not formally the same visualization, but just a thinking of like how could you visually emphasize the space where these values probably are not, right? So that was kind of a fun one. The other one that I was actually just thinking of was I think this was in the posterior one. It's going to be down near the ordinal stuff. This was a visualization that I created. This is partly tidybase, partly ggdist, but mostly ggdist down in these parts. That was sort of just trying to explain an ordinal regression model at various levels of abstraction, what the thresholds actually mean in those models and things like that. So this one's pretty complicated because it's this like multi-panel insanity. This one's also fun though because so one of the other reasons why ggdist is structured the way it is kind of like I have this ambition, which is I really want it to be the case that if you are writing Bayesian models in like a probabilistic programming language like Stan, that you can use essentially the same abstraction all the way from the point where you write the model to the point where you're visualizing stuff. That's why I want like this like distributional approach to visualization in ggdist. But also one of the things I've been working on more recently um, is within the posterior package, kind of in the Stan universe. Where the hell is it? This, yeah, oh yeah. I wrote a part of that package, which is the rvar data type, which is a random variable data type in R that's backed by a sample, right? But which acts essentially like an R array. So you can write code in R that's post-processing samples from a probabilistic programming language in a way that still looks like you're writing in a probabilistic programming language. And then you can also stuff those things into ggdist because ggdist understands rvar variables and allows you to visualize them. Um, so that this was kind of part of my ambition of like I don't want to leave like the probabilistic programming abstraction. I want to be able to carry it all the way through from fitting models to visualization. Um, but yeah, so this was another complicated beast. Uh,
Yeah, thanks.
yeah, yeah.
I also had two implementation questions, but I don't want to hog all the time. So maybe we do other questions first and we can come back.
Sure, yeah, yeah. And I mean I'm happy to hang around after. I've got time for more conversation if people want. Yeah, Michael.
Um, First, Matthew, I want to thank you for the work that you've done on ggdist. Uncertainty, I've thought for a really long time that uncertainty visualization, although it's a second order problem, is absolutely crucial to understanding data. Just a comment, there's some old publication by John Tukey that I can't remember offhand, where he discusses a number of these things, and maybe there are other things that you've never thought of or would like to, and maybe I can find the reference at some point or else email it to you.
Yeah.
Um, but here's a question for you. Um, Most of the emphasis and the implementation in ggdist is related to one-dimensional distributions. For two-dimensional data, which is all that common, you have the line ribbon.
Hmm.
And I thought for a while, or wondered for a while, if there are other ideas or other mappings that you could use to, I don't know, increase the versatility of showing intervals around fitted curves and things of
Yeah.
that sort.
Yeah. I think this is a great question. I have some thoughts about it. I don't necessarily have great answers. I think it's really difficult. I mean, there has been even just within the space of line ribbons. There are these interesting issues that come up, right? So the notion of like simultaneous ribbons versus pointwise ribbons. So ggdist does have support for simultaneous uh, ribbons that should have coverage over X% of the curves as opposed to pointwise ribbons, which don't. I mean, this was a big thing during COVID, right? Because you had there was a paper that was sort of critiquing some of the COVID forecasts, and one of the problems was, if a forecast was uncertain about where the peak was going to be, but not uncertain about how high the peak would be. If you do pointwise ribbons around that, you get something that looks like this, which actually makes you think that the peak is lower, right? So you want these like simultaneous ribbons that cover certain percentage. Um, I actually my feeling about this sort of more generally is I don't necessarily like ribbons a lot when it comes to visualizing uncertainty in functions.
One,
Let's see.
one idea that I had, I'm not sure how baked it is. It may be quite half baked, but um, using pattern
Hmm.
fill, pattern fill, as opposed to um, alpha channel transparency, um,
Hmm.
would give a different kind of flexibility in showing intervals of different, we're talking about kind of density around that fitted curve. But I think pattern fill is often underrated in
Yeah,
ggplot. And this
I
might be
agree.
one case where it would be useful.
I think that'd be fun. I think that I mean, I haven't looked into it that much. I know there's some packages for doing it. I also know some folks in the accessibility realm of visualization who are big advocates of pattern fill because certain other like it can be easier for some people to sort of see. It can also sort of survive lower fidelity transformations like printing things out or whatever. Um, the other thing that I kind of like with functions, I often think about more spaghetti plot type things, right? Because uh, the biggest problem that I have with ribbons is when you look at a ribbon, um, you're often deceived into thinking that, say this is actually a likely shape, right? You can't really tell what the correlation is between, if it goes up here, is it likely to continue going up or is it likely to revert back, right? And so I actually like representations that are more kind of spaghetti plots or even using animation to sort of give people a better sense of the distribution and the correlation between where the function is here and where it is there, right? Um, there's been some interesting research on this too. There's a bunch of people in the uncertainty visualization community who look at this mainly in the context of hurricane forecasts. Um, and because this is where you get things like misinterpretations of hurricane error cones. Often members of the general public will misinterpret hurricane error cones as telling you the forecasted size of the hurricane instead of a region around its likely center. And so you get these interesting misinterpretations, whereas things like spaghetti plots, I think people tend to misinterpret less. Uh, Other questions?
I was wondering if you could comment on kind of the uptake and like who is using ggdist and how it I don't know, patterns for like usage and how people discover it. I think there are like I'm curious how it lives in the ggplot2 extension ecosystem, because I think that
Hmm.
there's maybe other go-to like ggb swarm,
Yeah, yeah.
like you
Um,
might think of that first. I don't know if you wanted to do some kind of swarm plot, but it might not be the best choice.
it actually, in my obviously totally biased opinion, it is easier to use than GGB Swarm because it automatically figures out dot sizes and things like that, right? So if I want to do, if I want to do a B swarm, actually, I mean, I can change the layout here to a swarm if I wanted to, and if I wanted it to look sort of traditional, I could do that. Um, Actually, the color grouping is screwing up a bit, but there we go. So it figures out the sizing automatically for you, so you don't have to deal with that. It will never overlap. It will always make it sensible, right? Um, and yeah, so I've personally find it to be easier. There's a shortcut geom swarm that does most of this for you. Um, but in terms of uptake, yeah, I mean, I think it's been really interesting to me because I designed it again originally for uncertainty visualization. I didn't really even think about it as being useful for these types of uses, and then I saw some people, Cedric Shearer especially, who I think he picked it up a little bit. Solomon Kurtz picked it up, and some of those people started using it for visualizing things other than uncertainty, and so it's been cool to see that. But yeah, I mean, I don't necessarily advertise that. I guess I mean there's a vignette on it, but maybe the name or whatever else makes it the less obvious go-to for that. But again, this was like I was really annoyed at dot plots and I wanted to not spend my time twiddling with them, so I wrote a bunch of code in there that makes it so I don't have to. Um, so
Yeah,
yeah,
we can.
Joyce yeah, I don't want to. I don't know how
That's fine,
you're.
but I think we can do a couple more questions in the context of Q&A, maybe Joyce and Broder, and then we can go offline.
I just want to thank you very much for the package and for the talk. I really like the way that it's presented that as like kind of just a bunch of stuff that you can do what you want with, rather than like here's a chart type and this is how you make it, and here are the 6 geoms that you can use to make this chart. So it gives a lot of flexibility and really is in the spirit of ggplot2. I'm very excited for geom dots because I can't work with geom dot plot. It just doesn't do what I want it to do, and I don't know how many items are in each circle, and I really want to try this. My last question is very specific. When the one with the histogram with the 5 different groups,
Mhm.
and there I saw quickly a bunch of others like that. You're not the only one that does it this way, but I'm wondering why those always go to the right. It seems to me that they should point to the left so that the high values of
Hmm.
Y are on the right when you look at it the way you would normally look at a histogram.
That's an interesting question. I mean, if you want them to point to the left, you can certainly do that. Well, if I could remember how to use my own package. Yeah. So actually doing density. Oh, I have to do this after stat. Okay. Yeah. Yeah, if you wanted them to point to the left, you could certainly do that. Um,
Oh, wow. Amazing.
yeah.
Thank you.
Yeah.
Yeah, also from my side, thanks a lot for the talk. I have a very specific question. I didn't know about the geom swarm that you just showed. And if you maybe go back to your plot, one thing I always wondered is when you have just two dots, um, then one of them is always pointing towards, no, I mean, when you have a distribution like you had before, like with more dots,
Oh, okay.
then, for example, on the lower one
Oh, I
or
see what
on
you're
the
talking about,
right
like right
side.
here.
Yeah.
Yeah.
And I always like from other plotting packages, I always want to have them centered. And it
Hmm.
like is there actually a way to make it that you do not have the first point in the center and then you misplace the other one but that you have to that you can center them and the center line is running through the middle?
Yeah, I mean, I suppose you could probably construct a layout like that. I think I've seen ones like that. I mean, certainly with the normal dot or with the normal bin layout, I'm pretty sure that's how I have it. Yeah. Um, with swarm type layouts, it's maybe a little bit more annoying. Yeah, I don't have a implementation of that. I think some other packages do. In principle, um, I could probably add that. I haven't really thought about it. Yeah,
Yeah, this
I
was
guess that's
always
it.
it's a really, really specific question, but I didn't want the binning. I want to have the actual
Yeah,
values, but
you
then I
want to have the
was
actual
like
values, but you want to have it
centered in a way.
yep.
And especially when you have few values, then it really gets crazy because yeah, the whole thing looks like shifted to one towards one side.
Right. You're right. So that's part of the issue is so Gigi just doesn't have the only there are only two swarm layouts in gggist, this swarm one and weave, which is a different variant that I came up with. Um, and both of these have that asymmetric issue. Um, I only have these two because I don't like any of the ones that have that kind of lean effect. I'd have to think about if there's a variant of one of these two algorithms I could implement that doesn't have the lean but also allows that centering. I haven't thought about it. So I don't have a good answer to your question off the top of my head. Sorry.
Let me know when you find solution. I'm
Yeah,
really
yeah.
interested.
All
Thanks,
right.
Michael. Yeah, send me the email of that the two key stuff you were mentioning
I will do. I'll try to find it.
or like DM me on Blue Sky or something because I'm terrible at email.
Okie doke. Take care, everyone. This is so much fun.
Mm.
Bye
Thanks
bye.
for joining, Michael. Bye. Yeah, I'll stop the recording and then if anybody wants to hang out for a little bit, we can.